Today we're going to look at area between two curves. So this is section 7.2. And we've talked about this before. We've done some of these problems before. And I think we might have come up with this result right here. That if you're trying to find, if you're trying to find the area between two curves, f of x and g of x, then you would do the top function minus the bottom function, and you would integrate it. So, and the reason for that is if you think back to the Riemann sums, where you're finding the areas of each of these rectangles, think about if you were trying to find the height of these rectangles, the height would be f of x minus g of x. So this part right here is the height, and then delta x, of course, is the width. So this next statement says, as long as f of x is greater than g of x, then the area between the two curves is f of x minus g of x. So if you have something where they're intersecting, like say, here's f, here's g, and you wanted to find, let's say this. Say this was a and this is b. And you wanted to find the area between the curves, you would have to also find their intersection. And you'd have to find this area and then this area with two separate integrals. So it's important to graph your functions so that you can set them up correctly. This one is pretty simple. I guess we'll go ahead and do it though. I was trying to think about if I want to save time. So we'll graph this on the calculator. Okay, we've got secant squared, so that's 1 over cosine squared. And we have to square it outside. And then the other one was sine of x. And we're going from 0 to pi over 4. So let's just go ahead and set our window. And I'll see what happens if I leave it like that. Yeah, that's reasonable. And we know that sine passes through 0, 0, so this one here is sine. You can trace also if you want to verify that. So I'm going to re-sketch this over here so I can draw on it if I want to. So the goal is to find this area. Okay, it's going to be simple because the secant squared is on top, the sine is on bottom, and we're going to be integrating because we want area, so it's the integral of secant squared minus sine of x dx from 0 to pi over 4. So it sets up really simply, and then we actually know the antiderivative of secant squared because the derivative of tan is secant squared, so the integral of secant squared is tan, and then the integral of negative sine of x is positive cosine of x. From 0 to pi over 4. And let's evaluate these. Tan of pi over 4 is 1. Cosine of pi over 4 is root 2 over 2. Minus. Tan of 0 is 0. Cosine of 0 is 1. So we're going to end up with just root 2 over 2 because the negative 1 and the positive 1 are going to cancel. And it's area, so you could put units squared. So that one was pretty straightforward, kind of fun because we knew all the integrals. Okay. Next. Find the area. Now this one I could actually graph by hand because 2 minus x squared, I know what that looks like. So it's opening down, it's up 2 units here. And parabolas, since it's not stretched or compressed, are going to go down 1 over 1 here. And then you go over 2 and down 4. 1, 2, 3, 4. 1, 2, 3, 4. Oh, that didn't look right. It's supposed to be over here. Okay. Graph that. These points are important because I want to know where these two lines or these two curves cross. And then y equals negative x. So I'm going to graph these very carefully. Down 1 over 1. See how they're intersecting right there? Back 1, up 1, and it's going to intersect there. So those points of intersection are very important. And I didn't even have to use a calculator because these are both fairly simple functions. So we are going to be finding this shaded area here. And we're in good luck here because the parabola is above the line over the entire interval. So we don't have to break it into two sections. We can just go ahead and set up our integral. So it's going to be the top function, 2 minus x squared, minus the bottom function, which is negative x, so plus x dx. Integrating, and because I graphed it so carefully, I know I'm going from -1 to 2. If you did it on a calculator, you would find those points of intersection. And then you're just going to go ahead and integrate it. And you can try pausing this and doing it on your own. I'll just go ahead and give the answer here to save time, since you all know how to integrate and find those. I get 4.5 units squared. All right. Now this one we're going to use a calculator, 2 cosine of x and x squared minus 1, because it says we can. Whoop, I went too far up. 2 cosine x and x squared minus 1. And I think I'll start with a zoom. I like trig window on these. Let's do zoom 6. Or not 6, 7 is what I meant to say. Oh, that's pretty cool. That's neat. So it says find the area of the region enclosed by the graphs. There's only one region. It's this part right here. And so it's going to go from whatever this x value is to this x value. So we're going to need to find those. And let's go ahead and do that. So second, and hopefully you're following along with me doing this on your own. Enter, enter. I'll go back to the left here. Enter. Okay. So notice I'm getting a decimal. What we can do is let's store that to x, or maybe I'll store it to a. So what you can do, so you're going to store your x, you're going to go to a blank screen, second quit, and then you're going to do x store, I'm going to do alpha a, enter. And by symmetry, since if you look at the graph, they're symmetrical, that means that the opposite of that will be b. You could store it to b if you want, or you could just use the opposite of a when you integrate. I guess I'll go ahead and store it to b. So let's see. Oh no, I'd have to find it again. Let's do this. Let's just keep in mind that x, or a, is negative, whatever it was, 1 point something, whatever it was. And then I'll just use the opposite of that when I set up my integral. So my integral is going to be, okay, the top curve, that's the trig function, the 2 cosine of x, minus the bottom one, in parentheses, dx, and then I'm going to go from -1, so a to the opposite of a. Now, because we're using a calculator, that means we get to use fint. Math 9, and we've got, oh, and by the way, because I have these functions in y1 here, I'm just going to do y1 minus y2. That way I don't have to type it in again. So vars y vars function y1 minus vars y vars function y2, comma x, comma, I'm going to go from a, so alpha a, comma, to negative a, alpha a. Hit enter and I'm going to have my answer, 4.995 units squared. If they're allowing you to use a calculator, then it's important to use the calculator wisely and quickly. That's like storing the a and using y1 and y2. Those are ways to save time. This particular problem, I would like you to do this on your own. You guys can work in groups and then compare your results. So please pause this, do it on your own, compare your results, and I will say before you pause it that there are several different correct ways to do this. Okay, I'm going to show you the easiest one. I'll talk about the other ways. But please, please, please do this on your own, because you'll learn more if you try to figure it out by yourself. All right, so here I am. I'm back. I'm going to be figuring this out. So we've got y equals root x. I'm going to graph this by hand carefully. So the square root of 1 is 1, square root of 0 is 0, 1, 2, 3, 4. Square root of 4 is 2. And then the line x minus 2, up 1 over 1, up 1 over 1, up 1 over 1, and then up 1 over 1. So they're crossing right here at 2, 4. It says find the area of the region in the first quadrant only that is bounded above by root x, below by the x-axis, and the line x equals -2. So we're talking about this area right here. Okay, so like I was saying, there are several correct ways to do this problem. And the fastest way is actually involving some geometry. What you can do is you could think about the area under the curve, y equals root x, here. You could find that one easily enough. That would give you that entire yellow region, and we only want the blue region, so we could pretty easily find the area of this triangle and subtract it. In fact, let's do that. That's a 2 by 2, so the area is 2. See how fast that is? And then this integral is going to be pretty quick. The integral from 0 to 4 of root x dx. That's all there is to it. So if we do that, that's x to the 1/2. So if we add 1, that's x to the 3/2 times 2/3 from 0 to 4. That's 2/3 times 4 to the 3/2 minus 0. 4 to the 3/2 is the square root of 4, which is 2. 2 cubed is 8. So you get 2/3 times 8, which is 16/3. And then the area of the triangle is 2, which is 2, which is, 6/2, or 6/3 times 3 times 3. So it's 10/3, 16 minus 6. 10/3 units squared. Okay, let me talk about the other ways you might have done it, the other setup. So I'm going to erase all this. Get a nice big eraser here. I'm just going to show the setups. The other setup is you could have done the integral from 0 to, you could have broken it into let's see here. Yeah, if you go from 0 to 4, actually you have to break it into 2. So you could go from 0, actually this crosses right here. You could find this area right here first. That doesn't cover very well. So the integral from 0 to 2 of root x dx plus, and then find the integral of, find this little region, which is the integral from 2 to 4. 2 to 4 of root x minus the line, x minus 2 dx. So that's one way to do it. That takes more work, as you can see. And then another way you could have done it is you could have integrated from, let's go to a different highlighter. Let's see if it gets confused. You could have found this entire region and then subtracted out the area of this triangle. So that would be the integral from 0 to 4 of root x minus the line, x minus 2 dx. So that gives you that flesh-colored region. But then you have to subtract this area, which again is going to be 2, because it's a 2 by 2 triangle there. So you'll be subtracting 2 there. So there's 3 ways right there that you could have done this problem. this is another way to do it. Actually, I want to I'm going to wait on that for a sec. Let's go to here. Oh, am I missing some slides? Shoot, you know what? I'm missing slides. Aw. I was wondering about that. Shucks. Okay. I am going to put on a new slide here. What if you have a function g that's like this, and then f like that, let's say. And you wanted to find the area enclosed by the curves. Well, in this particular case, you can see it would be very difficult, I mean impossible, to do it with vertical rectangles. But what if you did it with horizontal rectangles? Well, that means we're going to be so the widths, look at the widths of those rectangles. Those widths are delta y, not delta x. So you can actually integrate with respect to y from A to B. So the integral for this one would be, oh, and by the way, you're going to do the right-hand curve minus the left-hand curve. So it's going to be f of y, it's with respect to y, minus g of y dy from A to B. That's going to give you the area. So this one is the right, this one is the left, this one is from the bottom to the top. Okay, now I can go back to to find my place, this one. Okay, so let's graph this one. I think I can do that by hand pretty easily. So y equals x cubed, and then 2, 8 is way up there. And then y squared. Ah, this is interesting. X equals y squared minus 2. So to graph that, we need to solve for y. So it's going to be x plus 2 equals y squared. Take the square root of both sides. You do need the plus or minus. So I've got plus or minus the square root of x plus 2. Root x is the parent function, and the plus 2 inside like that's going to move it left 2. So that means that instead of being here, it's going to go left 2, and it's going to go, the square root of 1 is 1, and then over 1, 2, 3, 4, and up 2. Oh. But they don't really cross there because 2, 8 is way up there. So they actually don't intersect there. And then the negative one is going to be the reflection of this one. So you've got, whoops, this one here, and then the reflection would be there. So that reddish colored curve is the y squared minus 2. We're going to be using horizontal rectangles. We're not actually finding the rectangles because we're going to do integration. Integrate. So you're going to do the right-hand curve, which is x cubed. However, if you noticed on that last slide, it's in terms of y. So what we have to do is we have to solve this for y. So it's really the cube root of y. Because the thickness of our rectangles is dy, then that means all of these variables in here have to be in terms of y. And then minus the right or the left-hand one, which is y squared minus 2 dy. So notice everything's in terms of y. And then we have to find where they intersect. So this one is clearly, this one is definitely 1 or negative 1, negative 1. And the other one we have to calculate on our calculator. That means we get to put these in our calculator. So x cubed is easy enough. And then this next one we need to put in as 2 branches. The square root of x plus 2 and negative square root x plus 2. And I think we'll try the window I had. Yep, that works great. Then we need to find that intersection. Second calc intersect. enter, enter, and I do want my guess is close enough. Fantastic. So I've got a decimal there. I'm going to store that to B. So that's 1.215. But I'm going to store it to B, so I need to do that. So go to a blank screen. X, store to alpha. I hope that's B. Yep, alpha B. Enter. So it has now been stored to B. We could certainly do this by hand, but let's go ahead and do it on a calculator just to make it faster. Math 9. Even though these are in terms of y's, on your calculator it's going to be in terms of x. Okay, we've got y to the 1/3, or x in this case, because we're typing it into our calculator, minus y squared, and then I'll distribute and get plus 2 there. Okay, that looks good. Comma, x, comma, -1, comma, and then b, so alpha b, enter. It's taken a while to think about that one. And we get 3.721 is the area. I kind of look at it to make sure it looks reasonable. Oh. Well, I was looking at this, because here's there's 1. This is like 2 kind of here, 3 here. I'm thinking it's going to be a lot bigger than 3.721. So, I'm not really liking my answer. I'm suspicious of it, and I just caught myself in an error. Does anyone see what it is? That was weird. Here on the graph, I'm really glad I saw this. You're not going from x equals, we're going from y equals -1 to whatever the y value is. So we actually needed the y value. This is incorrect. Okay, so let's redo this a little bit. So we need to go back and find that intersection again. Enter, enter, enter. It's the y value that we want to store to B. So that should be 1.793. All right, so I can quit y. So alpha, oh gosh, I'm going to have to find y on my other calculator because I can't see it on this one. It is 1. Y store to alpha b. Now I have the correct value in there. Now I could actually go, well, I better just go ahead and do Fn again. Math 9, and we have to type it in again. Y or x raised to, whoops, backspace, I want a parenthesis there, 1 divided by 3 minus x squared plus 2, comma, x, comma, -1, because that is the y value right here. This is the y value, -1, to this y value, which was alpha b, now that we've got it stored correctly. Okay, 4.215 is a lot better. Because it's definitely, I would say, easily over 4 units squared in there. Okay, so learn from that, it's the y's that we want here. So if I go back to here, I should have mentioned these are y and y equals. Super important, as we just discovered. Then, oh, we already did this one. We already did this. That's the way I showed you how to do it. What I would like you to do now, and what's on this last page? Oh, cool, we're almost done. Is to go back and do that example again in example 4, but integrate with respect to y. So that's this problem again. So integrate with respect to y, and do that on your own, and see what you get. Okay. Now, okay, now I will do it with respect to y. So I'm going to clear all this off. Well, all this. Oh, we already know the answer too, don't we? I just erased it. It was 10/3, so we know the answer. We can check our work. Okay, so the integral is going to go from the y's. So we're just doing this region right here. So the y is going to be from 0 up to this y value, which is 2. We're going to do the right-hand equation, which is the line, but it needs to be in terms of y, so that means that x is equal to y plus 2 minus the left-hand equation, which is this one, y equals root x. But that also has to be in terms of y, so that's x equals y squared, and then dy. And we could do that easily enough by hand, but just to save time, I'm going to do it on the, actually I'll do it on the calculator. Why not? Oh, I don't know why it does that. It's weird. All right, so math 9. Yeah, okay. Y plus 2. X plus 2 minus, you might even be able to do this faster by hand than by the time it takes you to type this all in. 0, 2. Go. That was pretty easy. 3.3. That's 10/3, isn't it? So this way is also a fast way to do this particular problem. And that concludes this lesson.